up, I want to talk a little bit about one of our key accomplishments in the area of energy storage research of late, and that is the battery fabrication and characterization lab that we have put in at the University of Michigan. Actually, our relationship in this particular space, the Phoenix Memorial Lab, goes back to 1956. After the Second World War, there was a strong interest, societal interest, in finding peaceful means of using nuclear energy, obviously. So the Phoenix Memorial Lab was built on that principle, and Ford actually funded the first experimental reactor that was in place. And arguably, U of M became a leader in nuclear energy research. So that gives you a picture on the right of the, on your left, of the lab as it looked at that time. It underwent a pretty extensive renovation. So about 2 years ago, there was a sort of a ribbon cutting. You can see this is quite a distinctive building if you ever get to the Out Ann Arbor on the north campus of Bonesteel. Kind of a neat front end of the building, kind of a circular glass space there. So that was an addition, a renovation of the building. So about 2 years ago now, there was a ribbon cutting for the so-called Energy Institute that's housed at the Phoenix Memorial Lab. And we set out to install then what would be kind of a centerpiece laboratory for energy storage research. So as Kevin mentioned, there's over $7 million from a combination of Ford and the state of Michigan, the Michigan Economic Development Corporation, and then the university also contributed some of the funds, and it's been designated as a Clean Energy Research Center that's funded by the Department of Energy. So you see the total rack up of investment there. We also, due to the nature of the laboratory, we were able to get some nice discounts from some of the key equipment suppliers and even have equipment donated since it was principally for education and research purposes. So operationally how this works is Ford's the industrial advisory board and oversees the management of the labs. And then U of M actually operates the lab, and explicitly we want U of M to operate this as a user facility. Of course, Ford's a key user, but it's open to all users. That can be run the gamut from large companies to startups to obviously professors and students at the university. The opportunity we think there is obviously one of the things we were considering. We obviously could have put this kind of a laboratory in-house at Ford. Would it be utilized 100% of the time? Would that be a good use of the capital equipment? And we felt that it would be better to make sure that it got fully utilized and was staffed by the professional staff at U of M. So that was sort of the compromise. I think the opportunity there is for us to, as Kevin mentioned, to work with our suppliers, not only our tier 1 cell suppliers, but sort of tier 2 material suppliers, separator suppliers, some of the key component suppliers. But maybe most importantly is to really educate the next wave of scientists and engineers that we need and that our industry needs to be knowledgeable about this topic. And really working in a facility, as you'll see in the next few images, that is really relevant, production-like facility. So this is the Phoenix Memorial Lab again. So looking over to the left is that glass area that you see prominently from the road. We occupy then most of what is the second floor of the laboratory, so towards the back of the building, 2 stories of the building, so a significant portion of almost all of the second story of lab is in fact this battery fabrication laboratory. Gives you an idea of the kind of space that's been dedicated to each of these areas. So I'll get into a little more detail. One of the important features of this lab is extremely low humidity, minus 40 dew point, that's less than 0.5% humidity. And I'll explain a little bit about why that's important. And this also includes some characterization, so beyond just being able to fabricate this, some of the equipment that we use for fabrication, we also can do detailed characterization of the finished product, the electrodes, the materials themselves, and the cells. So this gives you an idea. We actually have, I point out a couple of mixers here, a smaller and kind of what I call a medium mixer. I'll show you a little bit more detail of the largest mixer, but it's important that even if someone is only producing, let's say, tens of grams of material, experimental material that they're synthesizing in the laboratory, we're going to be able to process that in the same way that a large scale, it can be done at large scale. So we have different stages, different sizes of batches that can be produced. And then we have a fairly significant pilot line coater. That's the image on the right. After it goes through a coating process, then it goes through a densification. That's called a calendaring process. It's a fairly large piece of equipment. Then what you see here is an electrode slitter, so how we cut these down. And I'll show you a few images that'll make this make a little more sense. And this is what's in the dry room itself. So this is all the fabrication pieces of equipment. So we go from finished electrodes and start fabricating cells. a couple different types of cells, and again, I'll show you a little more detail about that. One would be a pouch cell that's a stacked arrangement of electrodes, the other would be wound. Again, that's all in the dry room. On the right is the winder, so that's a fully automated winder for winding cells. Nice thing about this lab, one of the things that I was really happy about is that these dry rooms are obviously heavily insulated, very dense walled structures. Normally, from an engineering standpoint, you just close the whole facility in and you sort of feel like you're in a large refrigerator. In this case, this was a really nice laboratory, and they actually had windows on both sides of the lab, so it's kind of unique to be able to have that much visibility outdoors. There's a nice pond and sort of fountains out there. So we went to the trouble of putting, I think it's 7 pane glass windows in to sort of preserve the daylight that was outside of the building, and the windows already in the lab. So we really preserved a lot of that. It's nice, it makes the facility a lot nicer, nice to have the daylight. A little more complicated, but well worth it. As mentioned here, we can make a couple different types of cells, and afterwards, if you're interested, I have examples of cells that were built in the lab up front. So one that we call a prismatic pouch just gives you the dimensions, and then what's traditionally known as an 18650 cell, so it's just 18 millimeter diameter by 65 millimeter height, a little round cell, cylindrical cell up front. Okay, with that, we're going to transition into a video.